Okay, again, I'm going to remind you that you can have your reference sheet. Hopefully you built it well enough yesterday that you're comfortable with it and you can find all the information that you need in a condensed space instead of digging through your notes and taking up so much time that you don't have time to finish. The calculator you need to have access to, whether it be your graphing calculator or your graphing utility, and then obviously you need some scrap paper or you need to use Notability for your scrap. Keep in mind that if you're going to use scrap paper, that if you're going to use pages like a hard copy paper, don't use front and back, use front and front, put them next to each other so you can take a picture at the end so it's easy for you to submit. It's way easier to submit one photo than it is to submit multiple photos, because then you have to pull them into Notability and then share it as a PDF. That takes time. All right, so questions on this first page. I know it says R1 and R2. It is B1 and B2. Now remember that your new book has different labels, but it's the same content. B1 and B2, which was the triangles, the circles, the intercepts, symmetry, and the graphing of the piecewise, or sorry, actually this one was just evaluating the piecewise function. This came later, okay? Any questions on this first page? These answers, like I said, are posted, but obviously sometimes we need elaboration. Okay. How about second page? Any questions here? This is the big one. This is the graphing calculator, and then find all the pieces. So all of this is one question on your test, and it is, I think I say round to the nearest 10th. Yeah, on your actual test, it's going to say round to the nearest 10th. And also think that these are going to be full out words. So negative infinity to infinity. No spaces. Negative infinity. God bless you. Yes, you know what? I will actually, this is one of the practice problems, so I'll like coach you through it right now. And then when we get to the practice problem that I have set up on Canvas, well, I will do it step by step on the calculator. What I would do is I would graph it, right? And then I would find my max and min values. So I would come here, I would find this max, I would come here, I would find this min, because the X values on the max and mins is what you use for your increasing and decreasing. That's when they change direction. And then I would also graph my zeros. So those, like I would kind of draw a rough graph of my graph, right? Or screenshot it if it's easy. And then label those points with those actual values. That way when you go to find, so like if I'm doing increasing, right? I know it's from negative infinity up to this point, and I use the X value. So it'd be negative infinity to negative 1.4. Then it's also increasing here again, okay? So I would do also from 2.1 to positive infinity. And then it's going to tell you, I think it says separate them with a comma. So you put a comma in between. Those are increasing. The decreasing is the in between. So it's here. And the decreasing goes from negative 1.4 to 2.1. But in order to know those values, you already have had to find the max and the min. So I'll walk through that one on the example. Like I'll open up the calculator and we'll walk through how to find the exact points. But that's something that I would do that first. Find the max and min, find the zeros, and then answer the questions. Because once you find the max and min, you can find the increasing and decreasing. And then the zeros are, remember, a list like this, negative 313. It's going to ask you to put them in order from smallest to largest. So just pay attention to that kind of stuff. And then the even, odd, neither. This is neither even nor odd, so you just write the word neither. Any questions? So you've got domain, range, increasing, decreasing, zero, relative max, relative min, and then even, odd, or neither. And I'll show you exactly, like I literally copied and pasted the question into a practice question so that you can see the exact format today, so the format doesn't throw you. The book ones, okay? So I only posted the evens on here because the odds are on Calc Chat. Keep that in mind. That is, oh shoot, that's actually the old book. Okay, I will post these odds because that is the old book. So slope, obviously 2 minus 2 over 8 minus a negative 3, 0 over 11, which is 0. That's the slope there. 9, 13, and 15 says to use the point on the line and the slope of the line to find the equation of the line. So here I use point slope. You don't have to, but I prefer point slope. Y minus a negative 1 becomes plus 1 equals 1/4 x minus 2. Distribute the 1/4. That would be 2/4 or 1/2. Subtract the 1. This is 2 halves, which is 3 halves. Then the next one, y minus 6 equals 0 times x minus a negative 2. And I get y minus 6 equals, this would be 0, this would be 0. Y would equal 6. That's going to be a horizontal line. And then undefined means it's an x equals, and you can't plug in undefined. So you've got to know that that's an x equals. I need to go x equals 10. You okay, Chase? Okay. All right, 17 is there. This one says, find the equation of a line that passes through the points. Use point slope intercept form if possible, and then use a graphing utility to graph the line. You will be graphing these lines by hand, so you won't use the graphing utility. This obviously is a horizontal line through -1, but you'll be asked to graph the lines y equals mx plus b. There's a lot of different questions in here, so I wouldn't say they're all going to be exactly like they are, but like in which ones specifically do you mean? I tried to keep the language similar, but it may not be exactly the same. You're welcome. All right, number 3, I don't do a paragraph leading into a question, if that's what you mean. Like the next one says, write the slope-intercept forms of the equations of the line through the given point that is A parallel to B perpendicular to the given line. Verify your result with a graphing utility. So we're using this information to find 2 equations, right? One in which it's parallel to this line and one in which it's perpendicular, which means I have to first find the slope of this line. -a over b would give me 5/4. And then I use this point. So y minus a -2 becomes plus 2 equals, for the parallel one, I keep the slope the same. And then y plus 2 equals 5/4 x minus 15/4. Subtract the 2, which becomes 8/4. And I get y equals 5/4 x minus 27/4. Then the perpendicular one has the opposite reciprocal slope. So slope's going to be -4/5. Still using the same point, y plus 2 equals -4/5 x minus 3. And then distribute the -4/5 plus 12/5. Subtract the 2, which becomes -10/5. So that's parallel and perpendicular, okay? 33 just says, does this represent a function? So remember, if the x repeats with a different y, it's no. So if I look at A, here's my x values. 1 repeats, it has a different y, which means this is a no. X can't repeat because it says to explain with a different y. This 10, 20, 30, 40, this is fine. This is a yes, okay, because the x doesn't repeat with a different y. Then comes the test based on the equation. So remember that y can't be raised to an even power or put in absolute value. That means that 35 is going to be a no, 37 is a yes, 39 is a yes, and 40 is a no. You will get 1. Identify a Jack, Daddy's calling you. You will have 1. Sorry. Jack. Yeah. Daddy's calling you. You will have 1 identify the function based on either the equation or points or the graph. So just realize it's dead. Here, call him. Sorry, folks. I have my children with me today, which is actually super fun for me. I have some company. Come say hi. Hello. That's Jack. His birthday is tomorrow. He's going to be 12. They said happy birthday, Jack. Thank you. He says thank you. All right. Next section was evaluating the function. So this we're just going to plug them in. So if I plug in 1 squared plus 1, that's 1 plus 1, which is 2. B, negative 3 squared plus 1 is 9 plus 1, which is 10. B to the third raised to the second plus 1 would be B to the 6th plus 1. And x minus 1 squared plus 1 is x squared minus 2x plus 1, or x squared minus 2x plus 2. (45). This is a piecewise function, right? So now it's saying if x is less than or equal to -1, I'm going to use this one. If x is greater than -1, I'm going to use this one. So for A, -2 is less than, so I do 2 times -2 plus 1, -4 plus 1, which is -3. 0 is also less than, so 2 times 0 plus 1, 0 plus 1, which is 1. -1 is less than or equal to, so 2 times -1 plus 1, -2 plus 1, -1. And 2 squared plus 2, 4 plus 2, which is 6. Questions on those? All right, domain of the function. So remember, this is where we're looking to see if it's underneath the square root in the denominator or the combination of both. For 47, it is in the denominator. This can't equal 0, so I would get x can equal -2, which is negative infinity to -2 union -2 to positive infinity. For 49, thanks, babe, this has to be greater than or equal to 0. So 25 has to be greater than or equal to x. X has to be less than or equal to -25, which means negative infinity to 25 with a bracket on the 25. 48 has the denominator. That's an issue. However, when you get a -1, there's no square root of -1, which means it's all real numbers. And 50 has your square root again. All right, the piecewise function, I'll work out this. I mean, the difference quotient, we'll work out that when we get to the practice problem, and then I'll post the one that has 53 on it just so you have the answer. Domain and range from a graph. So these you had to use your domain, you had to actually use your graphing utility to graph them, and then same thing. I can do this one. This would be domain is negative infinity to positive infinity, and range is, this is upside down, so negative infinity up to 3. 57. So this is left, God bless you, Jack, up. So the domain would be -3 to positive infinity, and the range would be 4 to positive infinity. This would be an absolute value, left 1, 2, 3, 4, 5, up 2. So domain is negative infinity to positive infinity, and range is 2 to positive infinity. 63, vertical line test. This is the third way to identify if something's a function. This is a yes and this is a no. If the vertical line hits it at more than 1 point, it fails it, then it's a no. All right, increasing and decreasing behavior I'll work on when I get to the, I'll put these answers on. Same thing for max and min because I'll graph those. All right, this last one I'll do on this page. So when it's less than 0, it's up 5 and up 1, 2, 3 over 1, down 1, 2, 3 over 1. So because it's less than 0, it's going to be an open dot here, and it's going to be pointing down that way. And then if it's greater than or equal to 0, it's x minus 4. So it's going to be a solid dot at 4, up 1 to the right 1. So open dot. Yep. Don't ever apologize for asking a question, Emily. I'd prefer you talk to me. Yep. Which ones? For the domain or for the... Okay, so when you say not equals, right? It means it can't include that number, and that's when you're going to get parentheses or an infinity, because infinity is not an actual number, right? So you can't include it. Those are always going to be parentheses. But if you say that it's just greater than or equal to or less than or equal to, we're saying it actually can equal that number. That's when you get brackets. So if x has to be greater than or equal to a number, then I would say that it starts at that number and it goes to positive infinity. If I would say x has to be less than or equal to a number, then I start at negative infinity and I go up to that number and it gets a bracket. So you want to look for the or equal to. The or equal to happens with an like a square root in the numerator, not in the denominator, right? But if it's in the numerator, you're saying it has to be greater than or equal to. Those scenarios are going to give you the actual brackets. But if the fraction's in the denominator, that's going to be I can't equal, which means parentheses. Or if the square root's in the denominator, it's also going to be a like less than or greater than, which means it's also going to be a parentheses. You're welcome. Sure. So this one, that what's underneath has to be greater than or equal to 0, right? So x has to be greater than or equal to 16, which means bracket on 16 pointing to positive infinity. Okay, and then again, I will go back and I will post these I'll repost this with all of the answers on there. Negative. Oh, this was an example, like what happens if it's x squared underneath. You can totally ignore that. I told you I wouldn't do that to you. That was just if it had said x squared instead of x. I think when I went over this one time, somebody asked what would that look like. I tortured them before. You guys get lucky. All right. Even and odd. Remember, if it's even, it's symmetric to the y-axis, or this, which this would be. This is a yes. And this is a no because it's a shift off of the x-axis. But if you had graphed it, you would have known that. Okay, or it says algebraically, which means plug in a negative x. Actually, hang on. I might be totally wrong. That goes back to the original. Yes, this is a yes. Yep, that's it. So these are even, not yes, evens. Okay, and then if I plugged in a negative x and it didn't give me, and it gave me the negative over on this side, all the signs were different, then that'd be odd. Okay, this says identify the parent function, describe the transformations, and write the equation. So this says that this would be 2. It looks like that's 1. Okay, so this is an x squared. It's right 2. It's up 1, which means I would get x minus 2 squared plus 1. Remember, I said I won't give you any non-grid transformations, so you won't get any that has like a narrow or wide. This is 1, 2, 3, up 3, so this is absolute value up 3, which means absolute value of x plus 3. All right, 97 to 103, I'll go back and work out later because you can use a graphing calculator to check those, okay? If you have questions on that and you need me to work one out, obviously I'll do it. But I'd rather get to the practice problem if we can. Any questions on those? So you don't have to use the function notation to write it. Don't stress about that. Be able to identify the parent function, describe the sequence, and then sketch the graph that you want to be able to do. Okay, combine functions. So f minus g. Again, I'll work these out unless you want me to do one now. I'll work these out and repost it. Does anybody want me to work one of those out now? Yes. So f 111. Don't apologize. F of 1 times h of 1, right, because that's multiplication, would be, so f of 1 is 3 minus 2 times 1 times whatever h of 1 is. So h is 3, 1 squared plus 1. So this is 3 minus 2, which is 1. This is 3 plus 2, which is 5. And then we multiply those together, and you'd get 5. Do you want me to do 109 too, Erica, or you're good? Okay. 109 is f plus g of 25. So I'm going to find f of 25, and then I'm going to add it to g of 25. So f of 25 is 3 minus 2 times 25, and g of 25 is the square root of 25. This is 3 minus 75, which is negative 72. Square root of 25 is 5. And then negative 72 plus 5 is negative 67. You're very welcome. Okay, this one's in there, so this is where we stop because this is the inverse. So in the notes, in the directions, I said to stop at 1/6. That we'll do next. Okay, that will be what we do on Friday, is the 1/6, which is the inverse stuff. Any other questions before? Yeah. So the way you test for even is take the x and replace it with a negative x. If you're doing it algebraically, right? That's your same test for the y-axis, right? So if I take this one and I get y equals negative x squared plus 6, y equals, that negative goes away. So if it goes back to the original, it is even, right? It would be symmetric to the y-axis, so it's even. If I was testing for odd, which it's not going to be, but just so that you can see it, you're going to do both the x to negative x and the y to negative y. So I would get negative y equals negative x squared plus 6, negative y equals x squared plus 6. Some of it goes back to the original, but not all of it, which means it's a no. All of it would have to either go back to the original or all of it would have to be the exact opposite. Odd would be both negative because odd is origin. Remember, origin is both. You're welcome. Yes. Yep. So this means h of g of 5, right? I go right to left. I'm going to take the g, so I would get the square root of 5, and then I take the h of that. So then I go to h, which is 3, and I plug it in. The square of the square root of 5 would be 5. 15 plus 2 is 17. I'll do 115 over here. This is f of h of negative 4. So now I start with the h. H of negative 4 would be 3 negative 4 squared plus 2. 3 times 16 plus 2. That's 48 plus 2, which is 50. And then I have to find f of that. So 3 minus 2 times 50. 3 minus 100, which is negative 70. Or sorry, negative 97. Yep. So 111, you see how they're right up against each other? That means multiply them. The open dot, like 113 and 115, is an open dot. That means take one, plug it into the other. So this FH or F times H like that is multiplying, where F of H is take the H and plug it into the F. So open dot's the composite one. You're welcome. Any other questions? Okay, because this is also inverse, right? Yeah, this is still inverse. So ignore that last page. Any other questions before we get into the practice questions we're going to do together? Go to Canvas. I think I put it on the module, but also if you go to quizzes, you're going to see something that says today's date. Jack, you're on, right? Okay. It says today's date. It's under practice quizzes. NG B1 to B5 extra test practice, and I want you to click on that. And then go ahead and start it. So I only put 3 questions here, but I would say that these are 3 of the like harder-ish ones, or at least 3 different types of format entering of your answers. The first one's the difference quotient. So I'm going to work these out with you, okay? But the difference quotient is going to be fill in the blank just like that. So you're going to come back to this space and then you're going to type in your answer. So let's do that one first, okay? So the difference quotient, if it's 7x squared plus 2x minus 6, remember I have to do f of x plus h minus f of x over h. So first I'm going to find f of x plus h. I'm going to take this and plug it into both the x's here. 7x plus h squared plus 2x plus h minus 6. Now we're going to have to do x plus h a lot, x plus h squared, so you might as well memorize that. So it's 7x squared plus 2xh plus h squared. Distribute the 2 in here, plus 2x plus 2h minus 6. Distribute the 7. If I could combine like terms, I would. I cannot. So that whole thing is f of x plus h. You with me so far? Yeah. Okay, then from that we are going to subtract f of x. That f of x is that whole initial question, 7x squared plus 2x minus 6, which means this minus gets distributed. So 7x squared plus 14xh plus 7h squared plus 2x plus 2h minus 6 minus 7x squared minus 2x plus 6. If you've done that step correctly, things should cancel out. So 7x squared and negative 7x squared, 2x and negative 2x, negative 6 and positive 6. Now what's left is 14xh plus 7h squared plus 2h, and I put it all over h for the last step. Cancel the h's, 14x plus 7h plus 2. Me too. Me too. All right, so then when you type that in, remember it's fill in the blank. So it'd be 14x. Let me see if I can zoom out. Nope. Shrink that.
Jack is here.
All right, so you're going to enter it just like that. No spaces, okay? You won't do a single space on anything. That's really too tiny, huh? There won't be a single space on anything that you type an answer in. Questions on difference quotient? Sure. Difference quotient is a long process, but it's the same process every single time. So hopefully it's not so bad. Okay, but if you haven't done it, if you didn't do the review, you need to do the review, because obviously I'm not going to test you on something that's not on that review, but if you don't do the review, you're not really preparing. All right, then question 2 is your graphing utility question. So you're going to have to graph that function. Let me get this guy over here. Okay, we're going to graph that function. So I'm going to type it in. Carefully. So 4x to the 5th plus 8x to the 4th plus 2x to the 3rd plus 2x to the 2nd minus 1. I'm going to make sure my signs are right. I'm going to make sure my exponents are right. I'm going to hit enter, and then I'm going to graph it. All right, so I get both the peaks and the falls in this. If I didn't, I would make sure I would adjust my screen so that I can include it all, okay? I'm also going to show you how to do this on the graphing utility, so on the app, so just keep that in mind. Everybody with me so far? So what I would recommend you do is take a screenshot of that picture so that you can draw on it and label those points. It's going to tell you have to include a picture of this on your answer sheet, okay? You're not actually going to upload a picture of it into the question because I couldn't do file upload and multiple blanks, but it's going to ask you for that picture at the end. So you're going to make sure you take that picture. Just draw it. Yeah, you can just draw it. You're going to want it because you're going to need, good question, you're going to need to know what those points are. So I would just draw it, like as loose as you can, but you want to at least label your max and mins because that's going to help you with your increasing, decreasing. Okay, so now I'm going to find those max and mins, right? So I'm going to go second, trace, and I'm going to go to max. I have to go left of the max, which there's only one. If there's more than one, I'm going to do this multiple times. I have to go right of the max, and then I'm going to let it guess. And I get negative 1.5, so I'm going to label my graph, which I'm going to write this down because I can't exit out of the video. Negative 1.5, and I'm rounding that to the nearest tenth, and then 6.9. Like I said, I'm going to keep going. I can't keep pausing the video, okay? Then I'm going to go second, trace, and this time I'm going to go to minimum. Go left of my minimum. Oops. Go right of my minimum. Hit enter, and it's going to take you to the minimum. That 1.032 to the e to the negative 6 means there's 6 zeros in front of the 1, which means the min is 0, negative 1. Again, we round to the nearest tenth. The other thing I need my calculator to find for me is my intercepts. My my x-intercepts are my zeros. So I'm going to do second, trace. I'm going to go down to 0. I go to the first one. There's 3 places that this crosses the x-axis. Go left of the first, right of the first, and that's negative 1.9. I only need the x value on that. When you're doing a graphing utility, you're not going to be able to get an open dot, closed dot. It would only happen if you were graphing piecewise functions, which we're not doing. Well, it will be a parentheses for increasing, decreasing. Yes. For domain and range, it depends. If this was a parabola that I didn't go south of like a negative 1, then it's going to be from negative 1 to positive infinity. And that would get a bracket. Yeah. Okay, so then you're welcome. Other 0, go to the next one, go left of that, go right of it. Enter, and it takes me to the next 0, which is negative 0.6. Last one, second trace, go to the last 0, left of it, right of it, enter, 0.5. Okay, let me pause this. So then when I go to graph this, let me shrink that. Okay, I would know that these points, so I'm going to label it, but I would have said you should do this while you're doing it because it would have been better. This is negative 1.9. This one is negative 0.6, and this one is 0.5. The max here is negative 1.5, 6.9. The min here is 0 and negative 1. Now that already, yeah, go ahead. It's going to say round to the nearest tenth. Yes, Erica. Okay, so if I look at this graph, remember my arrows are here and here. The domain is negative infinity to positive infinity. The range is negative infinity to positive infinity. But it says it'll say in your directions, infinity is the word infinity. So I will type that in as negative infinity, comma infinity, no spaces. Please, for the love of God, I would have had to check 800 times for your mistakes like that. So make it easy for me. Remember, the easier it is for me to grade, the happier I am, the more partial credit you get, the better everybody's grades are. Make it easy for me. Yes, Sophia. No spaces. I just made it a blanket thing, like no spaces on any of the fill in the blank. Okay, same thing for the next one. Negative infinity, comma, infinity. Okay, then we look at our increasing and decreasing, right? So I know it's increasing from here to here, and then again from here to here. So the increasing is going to be from negative infinity up to the x coordinate on my max, which is negative 1.5. So it's going to be negative infinity, negative 1.5. And then it happens again from here, which is 0, to positive infinity. So I'm not, it says put a comma between. That's what it will say to do. 0 to positive infinity. Still no spaces. And then it's decreasing from here to here, which is from negative 1.5 to 0. Just like that. It's always the x. Yep, the increasing, decreasing is left to right, so it's always the x. The only time you use the y is if you're doing range or if you're finding the max min, right? Because that's going to be a coordinate point. There's no flat spots on this graph, so my constant is d and e because I'll put, if no answer, d and e for does not exist. Now my relative max and min are the points we found. Here's my relative max. Negative 1.5 and 6.9. No spaces. My min, 0, negative 1. The zeros I list in order, least to greatest. If there's more than one zero, separate with a comma. Still no spaces. So the furthest left is negative 1.9. The next one would be negative 0.6. The next one would be 0.5. I think I gave you the 0.6 and the 0.5. Like I gave both options if that was something like that with and without the 0. But, oh, where'd it go? Well, that's weird. But don't forget your negatives because it will mark that wrong. And make sure it's in your code. Here you want. I have this one and that one. That's like a pullover. It's black, so you should be okay, right? All right, questions for me on that one? That's a big one. It's like 20 points. Oh, and then there's even, odd, neither, right? Underneath it's even, odd, neither. There's the mess. And this is so neither. Now I'm going to find the... That's the worst. This would be a neither. Okay. It's not symmetric to your y-axis. It's not symmetric to your origin. It's like semi-symmetric. It's not semi. It's kind of close, but because of these being evens and these being odds, my x's on this one are going to change to be negative. And this one it's going to change to be negative. But the negative one isn't going to change. And the positive, the x squareds are always going to go back to. There's your piecewise function. So this is graphs of piecewise functions. So first of all, if you're doing this by hand, you have to be really, really, like if you have a piece of scratch paper and that's what you're going to use, please be very, very accurate with these points. If that means printing a graph, like if you have graph paper, use it. If you need to print graph paper, there's a website called freegraphpaper.com and it has free graph paper. That's the name. I'll post a link to that. If you don't have a printer at home and you are going to do it by hand, just make sure you're very neat. Make sure your spacing, okay, is accurate. Don't go like this one's going to be like this. This is going to be like that. That's not an accurate graph, okay? So just keep that in mind. So I'm going to pull in, practice what I preach, right? I'm going to pull in my coordinate grid. If you're using Notability, you can use the sticky. All right, so it says, this one is the one you're going to take a picture of. Remember the process here. So we're going to, this is not part of it. It'll say take a picture of just this answer and upload it. So I'm going to say that for x values being less than or equal to 2, less than or equal to negative 2, y is equal to negative x plus 1. So I just reshuffle the order there so that it's in y equals mx plus b format. I go up to 1. My x is negative 1. So now down 1 to the right 1 or up 1 to the left 1. And that would be my original line. but it says only for the values less than or equal to -2. So I really only want to start here and then go left of here. So now I'm going to erase this to the right of -2. Then it says it's x squared if x is in between -2 and +3. So x squared would be a solid dot here. It'd be up 1 to the right ones on either sides. And this time I need exact points at -2 and +3. So I'm going to plug those points in. If I plug in -2, I actually get 4, which means my graph goes all the way up to here. And it's an open dot because it's not an or equal to. The 3 on the right, if I plug it in, 3 squared is 9, which means my point goes all the way up to here, and that's a solid dot because it is or equal to. So you need to have accurate points. Obviously, feel free to use your parent functions and your translations to figure out what they look like, but you need exact points on these. And then the last one says it's just 5. So this would be a y equals 5. What kind of line is a y equals 5? Oh, that better. Good, horizontal, okay? Which means it's going to have an open dot at 3, 5. It would be an open dot here, 3, 5. And then it's going to be an arrow pointing towards the right. So this had 3 parts to it, okay? It's still a piecewise function. I'm not going to do more than 3, although they do exist. You could continue, but just keep in mind it could be 2 parts, it could be 3 parts. It could be absolute value, it could be squares, it could be cubic functions, it could be lines. It's a mix of all that stuff. Yep.